In this video, we are going to talk about dissolution. And dissolution is the process of dissolving. And it looks more, oh, whoops, I meant to write. Uh, in this video, we are going to look at dissolution. And dissolution is part, in this video, we are going to look at dissolution. Dissolution is part of dissolving. Dissolution looks more at the molecular or ionic level and really discovers what is going on with these different particles. How are we forming this homogeneous mixture? How are we forming the solution? And the solute particles disperse and interact with the solvent particles in order to make that solution. So as you start this dissolving process, this is cyanide in here with a potassium cation. They are going to start separating, and those water molecules are going to completely surround the individual ions. And this has an ion dipole force. When it happens, the cations are going to interact with the oxygen in water because they're going to be attracted to the partially negative charge. The anions are going to interact with the hydrogen in water because they are going to be attracted to the positive charge. The molecule is going to move around. If your solvent is a molecule and not an ionic compound, it's going to move around and it's still going to be completely surrounded by water. So the electronegative atoms of your molecule are going to interact with the hydrogen and water, whereas the electropositive atoms are going to interact with the oxygen in the water. And you get this orientation where the water will completely surround whatever the solute particles are. When you're dealing with solids and liquids, if you increase the temperature, you're going to increase the solubility. So in this graph, we have some different solid solutes, and we can see the different ways the solubility is changing with a change in temperature. So as we increase our temperature, most of these substances, their solubilities shoot up. Some actually get lower. With gases, the opposite is true. If you increase temperature, the gas solubility decreases. So it decreases solubility. And we can see this with soda pop. If you have some soda and you don't finish it, if you put it in the fridge or somewhere cold, the carbonation is retained a lot longer than if you leave it out on a hot, sunny day. If you increase the surface area of a solid, it is also going to increase solubility. If you made that more exposed, where the water molecules or the solvent molecules can completely surround it, it's going to increase that solubility. Stirring can also help increase solubility. Sometimes when you stir, you're actually increasing that surface area because you're breaking the different clumps of solid up. Increasing the concentration can decrease the solubility. If there are fewer solvent molecules compared to the solute molecules available to interact at the surface of the solute, then they're not really going to be able to surround it.